Okay, so in this example, which is again taken from the JL Merriam book and is one of the example in your tutorial sheet. Uh, okay, so this is obviously oblique impact. Okay, so a ball is projected onto a heavy plate. So this 2 is a body which is a heavy plate, and with a velocity of 16 meter per second. So the velocity of the ball is 16 meter per second, and the angle is also given, which is 30 degrees. If the effective coefficient of restitution is 0.5, so the coefficient of restitution between the two bodies here is 0.5. So compute the rebound velocity v dash and the angle theta dash. So you need to calculate the rebound velocity of the ball and obviously its angle. So as you can see in this case here, so the given data that you are given v1, which is 16 meter per second, and you are also given theta 1, which is 30 degrees here, and you're also given the coefficient of restitution, which is 0.5. And what you need to calculate need to calculate v dash, and you also need to calculate the angle associated with this velocity, which is theta dash here. So as you can see in this case, that this is a heavy plate and the ball is coming in this direction here. Okay, now in this case, you know, the solution will be that this is obviously a case of oblique impact, and we know that in case of oblique impact, we can split the problem into n and t direction. So the t direction is along this direction here, which is tangent to the point of contact here, and the n is then in this direction here. So this is our t direction, and this is our n direction here. So as you know that the that along t direction, we know that there is no force or contact force in the t direction. So therefore, the velocity or the momentum of the particle will conserve. So in t direction, okay, you can write that g1 should be equal to g2. But this is just for particle 1. Yeah, so m1 v1 t in tangential direction here is equal to m1 v1 dash t. So this equation is only applicable in t direction here, and again, because this m is on both sides, so we can cancel m. So what we will get that v1t is equal to v1 dash t. And now, as you know that this velocity, which is v1, can be split into two components, which is a t component and an n component. So this is our incoming velocity here, and this is the outgoing velocity. So the incoming velocity can be split into two components. So one is this component here, and one is this component here. This is the incoming velocity. So this component is this is v1 and this is v1n, because this is our n direction and this is our t direction, and this is v1 t. Similarly, this v2 or v1 dash can be split into two components. So one is this direction and one will be in this direction. So this one is v1 dash n, and this one is v1 dash t. So we have these two component of the velocity, and this is obviously 30 degrees, and this is theta dash, which is unknown in this case. So in this case, we can calculate v1 dash t, which is equal to v1t, and v1t we can calculate from here, so which is 16. So this is 16 cos of 30 degree. So which you can calculate is 13.86. Okay, so after calculating this t, now we need to calculate this vn. So vn is again, now we need to use another equation. Now it's very important to realize that because in this case you have one particle, which is ball in this case, and another is a plate with a heavy plate, which you can say is with a mass of infinity, or with infinite mass. So therefore, we cannot apply the law of conservation of momentum to the system here. So we will use the equation, which is the coefficient of restitution here. So E, which is, we know, is that uh, the relative velocity of separation, and divided by the relative velocity of approach. But obviously this will need to be applied in n direction, as we discussed in the theory. So in this case, we know that it should be v2 dash n minus v1 dash n, and then v1n minus v2n. So all the components of the velocity should be in n direction here. And as you know that the 2 is this plate here, so which is a heavy plate and is not moving at all. So this means that the velocity of this is obviously 0, and its velocity before impact and after impact is 0. So you can just remove this v2 dash and v2n here. So the only thing which will left is these two term here. So on the left hand side, we are given E, which is 0.5, and then on the right hand side we have v1 dash n, which we need to calculate, and you have this minus v2n. So v2n is uh, sorry, v1n. So v1n is this this velocity here, and in this case it should be and again you can see it's in the negative direction, so you just put it a negative here, so it will be minus, and v1n, so which will be 16 sine of 30. Okay, so now from here you can calculate v1 n dash, which will be 13 point which will be 4 meter per second. So you calculate this value of the of the v1n, and you can see that v1n is positive, because this negative and negative will give you positive here. So we managed to calculate v1t, which is this value here, and which one was positive, and we calculate v1 n dash, which is this value here. So now from these two values we can calculate the magnitude of v dash. So v dash will be just equal to v1 dash t square plus v1 dash n square under the root, and from here you will get 14.42 meter per second. And similarly, if you want to calculate this angle, which is this angle here, theta dash, so theta dash is just tangent inverse v1n dash and divided by v1 dash dash t here. So if you just put the values here, the angle that you will get will be 16 10 degrees.